NASTRAN structure. Here it is. Alright, so I'm going to go ahead and do the FEM. So, in my FEM, I'm going to go ahead and create my 2D mesh collector, so shell. I'm going to come over here. It has a thickness of 0.2. Material, in this case, for this one, 6061. I'm not doing anything too fancy. We want to make sure that we mesh it appropriate. So we discussed last time about putting mesh points in the boundary condition. Everybody remember that? We discussed we're going to pull on this from this side and this side, right? So we have to make sure we don't have rigid body motion. We have to make sure that it deforms the way we want it to deform. So the only way we're going to be able to do that is create mesh points. Now obviously the center of this plate is not going to move, right? When we apply it, but this hole is going to move around, right? So if I put a boundary condition here on the end and then my hole is going to go over here, something's not going to go right. I'm only asking for trouble. Okay? I'm trying to put a mesh point somewhere that may end up being a void right there, right? There's going to be a cutout. So I can't have a mesh there. So I have to watch out for stuff like that. All right, so I'm going to come in and add my mesh points. Here's my mesh point. All right, so I have my mesh points in. The whole purpose of that is I'm going to do my boundary condition. And of course, when we do geometry optimization, all our forces, all our constraints must be geometry based. Okay? I can't put a constraint on a node. I can't put a force on a node. Because it won't be able to move when the geometry changes. All right, so now that I have that, I'm going to go ahead and do some mesh control. So I'm going to put 60 nodes on this, or 60 elements. And this whole thing is I want to make sure I'm going to have high stresses on this circle, right? So I want to make sure it's appropriately meshed. I could have used a finer mesh if I wanted to, but this is what I'm going to use. All right, so I have my mesh complete. So now I'm going to go in my sim. I'm going to turn off my mesh because I don't want it on. I want to make sure I pick the appropriate points. All right, so user defined constraint. I'm going to pick my mesh points. So I have those two mesh points. I'm going to go ahead and I have everything fixed, but that's not what I want. What do I want here for the boundary condition? So I want it free in. So free in degree freedom 3, right? The z-axis. Okay. All right, so I've got that one, and then I'm going to come over here and grab the other two, and the other two I want fixed are actually free in what degree of freedom? Fixed along the y. So I'm done. So I have my boundary conditions. The only thing I need are my constraints. So I'm going to go ahead and apply my forces. So I have the force along that edge. And then I'm going to come over here. Alright, so I have everything I want. So now I'm ready to go ahead and solve it. This is, of course, where we ran into problems last time. So it should work fine. hopefully, maybe. All right, and it ran, it's done. I'm gonna go ahead and close it. There's my results. There's my displacement, so this is how it's going to deform. And that's okay, I mean, that's really what it's gonna look like. All right, so now I've just gone through the initial step of basically setting up the optimization. So we create our mesh, we can create our constraints, create the forces that are on my mesh. Now that I have all of this, I run the analysis, I get a solution. Now that I have my solution, then I can go in and start the optimization part. Okay? So this is the first step, so now I'm gonna go back. I'm in my FEM. I'm gonna scroll all the way to the top. And right here is my sim, right? I'm gonna click on that. I'm gonna right click. I'm gonna come down here to new solution process. And these are all the things that we have available to us. Of course, a lot of stuff is shut down now. The shaped optimization, topology optimization, very similar kinds of things that are pretty neat, but I don't think they're working. This is our geometry optimization. This response simulation, if I had shown you how to do things based off of time, so in other words, we can take something and we can apply a force, pull 100 pounds for 10 seconds and then release it, we can simulate that. Okay? And we would do that with this response simulation. So we can do time-based stuff, and for every node in our model, we're going to have 6 degrees of freedom, right? So for every